We're told that the curve C is defined by the parametric equations x is equal to sine theta and y is equal to 3 cos 2 theta. We're asked in part A to find the equation of the tangent to the curve at the point P, where that should be theta is equal to pi over 3. Change that. Give your answer in the form y is equal to mx plus c, where m and c are exact values. So let's make a start with part A for this question. Okay. Right, so for part A, we want to work out the equation of the tangent to the curve. So if I just do a quick sketch, now I've got no idea if the curve actually looks like this at the point P, but let's say that it does. Okay, let's imagine this is the curve C, and then when theta is pi over 3, let's imagine we're at this point. Okay, so if I just carefully draw a tangent line, there we go. So that's my tangent line to the curve at the point P, where theta is pi over 3. So what we should notice is at this point, the line, the tangent line, has the same gradient, the same instantaneous rate of change as the curve at that point. So if I work out the gradient of the curve C at that point, I automatically work out the gradient of the tangent, which we should remember from GCSE is going to be the m in y equals mx plus c. I also know that at the point P, the line, the tangent line, has the same coordinates at the point P as the curve does at the point P. Now I know that at P, theta is equal to pi over 3. So to find out the coordinates, the Cartesian x and y coordinates of this point P, I need only substitute in theta is equal to pi over 3 into my parametric equations. Then I will be able to work out C. So without further ado, let's have a go at this. So first of all, I want the gradient of the curve. So the gradient of C. So I need to remember that the equation for the gradient of a curve, for a curve defined by parametric equations, dy by dx, is just dy by d theta. So the derivative of y with respect to the parameter, divided by dx by d theta. So we can substitute in y and x in order to find out what these values will be. So dy by d theta is just going to be the derivative of y with respect to theta. So remembering my chain rule, that is going to be the inner function differentiated, so that's going to be 2. So obviously the 3 is carried forward. I get 3 times 2 times minus sine of 2 theta. That is my dy by d theta. All of that needs to be divided by dx by d theta, which is a very easy cosine theta. Okay, I've just done dx by d theta. So we have dy by dx is equal to 3 times 2 times minus 1 is minus 6. So I have minus 6 sine 2 theta over cos theta. Now, when theta is pi over 3, we will have the gradient at the point P, so the gradient at this point here. So theta is pi over 3 will mean that my gradient is equal to, so I'm going to say dy by dx when theta is pi over 3, is going to be minus 6 sine of 2 pi over 3 over cos pi over 3. Now, we should really know these values, so I think sine of 2 pi over 3 is sine of 120, which would be 1, and I think cos, not 1 even, no, sine of 60 is root 3 over 2. So I think you'd have basically root 3 over 2 minus 3 root 3 over a half. I think you end up with minus 6 root 3. But realistically, we have a calculator now in A level, so we can just put the values in. So first of all, making sure that I'm in degrees. Not degrees, making sure that I'm in radians, sorry. Minus 6, being very careful to sub it in properly, minus 6, 2 pi. That's just basically, and I'm doing two lots of pi over 3, 2 pi over 3, over cos of pi over 3. That gives me, as I said, minus 6 root 3. So that's basically the slope of the curve at P, and I've drawn it going up, but realistically it should be going down, but just a sketch, just to help us visualize the situation. So that is the gradient of the tangent line as well. So I can say the gradient of the curve at pi over 3, at theta is pi over 3, is minus 6 root 3. Therefore, the gradient of the tangent line to the curve when theta is equal to pi over 3 is equal to minus 6 root 3. So I can say the equation of the tangent, now just bear in mind, you might prefer to use this form, y minus y1 equals m bracket x minus x1. There's no problem with you doing that, but I want us to use y equals mx plus c here, because that's what the question specifies. So the gradient of the tangent is going to be y is equal to minus 6 root 3 x plus c, and c is not to be confused with the equation of the curve, it's just the y-intercept of the tangent line. So I need to know 2 points, I need to know a single point, the coordinates of a single point the tangent line goes through, which is obviously going to be P itself. So I need to find out what x equals when theta is pi over 3 and what y equals when theta is pi over 3. So I can say when theta is equal to pi over 3, x is just sine theta, which is sine pi over 3, which will work out to be root 3 over 2, but I'll just show you on here. Yeah, root 3 over 2. And y is just going to be 3 cos, so 3 times cos of, what's it cos? 2 theta, so cos of 2 pi over 3. Which is just minus 1.5, minus 3 over 2. Okay, so we have our x and y values. I can substitute those in carefully into my equation for the gradient of the tangent, for the equation of the tangent, sorry. So I have minus 3 over 2 is equal to minus 6 root 3 times root 3 over 2 plus c. And obviously my objective now is to get c. You could just put the right-hand side, or the numerical expression on the right, you could put that into a calculator nowadays and it would work. So minus 6 root 3 times root 3 over 2, that would work fine. And you can see that's minus 9. So you end up with minus 3 over 2 is equal to minus 9 plus c. But just as easily, root 3 is 3, 6 3 is 18, minus 18 over 2 is minus 9. Okay, so we have minus 3 over 2 equals minus 9 plus c. To get c on its own, I'm going to add minus 9 to both sides, giving me c is equal to 9 minus 3 over 2, which is simply 7.5. So now I know m, I know my gradient, minus 6 root 3, and I know the y-intercept, 7.5. So the equation of the tangent is simply y is equal to minus 6 root 3x plus 7.5. Remembering to leave it like this because I want exact values. Part 2 of the question asks me to find the coordinates of the points of intersection of the curve C and the straight line y plus 3x is equal to 3. So we'll do that here. So let me remind myself of the equations. So we know this is for part B now. We know x is equal to sine theta. We know y is equal to 6 cos of 2 theta. Let's check that wasn't a 3. No, it was 3. Sorry. 3 cos 2 theta. And I want to know where the equation defined by those where the curve defined by those parametric equations intersects the line y plus 3x is equal to 3. And we simply do this by substitution. Wherever I see x in this equation of the line, I can just replace it with sine theta. And wherever I see y, I can replace it with 3 cos 2 theta. So we end up with 3 cos 2 theta plus 3 sine theta is equal to 3. And we essentially have a trigonometric equation, and we need to solve it, but we don't actually have to go all the way. We don't need to find values of theta. We need only find values of sine theta. Now, what we're going to need to help us is the double angle formula for cos. So in your formula book, you should be given the compound angle formula, cos A plus B is equal to cos A cos B minus sine A sine B. Now imagine that B is equal to A, and that will give you cos of A plus A, which is 2A, and this is an identity, is equivalent to cos A, which is cosine squared A, minus sine A, which is sine squared A. So just remember, cos 2A is cos squared A minus sine squared A. So I have, and also remember, cos squared A, if you like, plus sine squared A is equivalent to 1. So that means that cos squared A is equivalent to 1 minus sine squared A. So cos of 2A is equivalent to, I can just replace the cos squared with 1 minus sine squared, 1 minus 2 sine squared A. So that will help us now solve this equation. So we have 3 cos 2 theta, but I can just think of that as 3 lots of this, plus 3 sine theta is 3. Well, actually, the easiest thing to do would be to divide everything by 3, divide both sides by 3, because then I just have cos 2 theta plus sine theta, I'm just, 3 divided by 3 is 1, it's equal to 3 divided by 3, which is 1. I can now use my double angle formula to write cos 2 theta as 1 minus 2 sine squared theta. So I have 1 minus 2 sine squared theta plus sine theta is equal to 1. What I can do now is subtract 1 from both sides. So I simply have sine theta minus 2 sine squared theta is equal to 0. I've just taken away 1 from both sides. Finally, I can now take out a factor of sine theta, giving me sine theta bracket 1 minus 2 sine theta is 0. So either sine theta is 0, or 1 minus 2 sine theta is 0, which means that sine theta would have to be a half. I've basically done this. 1 minus 2 sine theta is 0. Add 2 sine theta to both sides. Divide both sides by 2. I've just done that. Okay, so we have 2 possible values for sine theta. So what I need to do now is just recognize that I'm looking for values of x and y. So I either have sine theta being 0, or sine theta being a half. Now I know that x is equal to sine theta itself, and I know that y is equal to 3 cos 2 theta. But we know from what we did in red up here that cos of 2 alpha, or cos of 2a, is 1 minus 2 sine squared a. So I can say y is 3 times 1 minus 2 sine squared theta. Okay, so If sine theta is equal to 0, we have x is equal to sine theta, which is 0, and y is just 3 times 1 minus 2 times 0 squared, which is just 3. So I have 0, 3. That will be one solution. Or if sine theta is a half, we get x is equal to 1/2 and y is equal to 3 times 1 minus 2 times a half squared, which is a quarter. So y is just 3 times, so that's a half. So I have 1 minus a half, which is a half. Now you can use a calculator for that if you like, which is just 3/2. So we have solutions, or I'll tell you what, better terminology there, points of intersection. The points of intersection of the line y plus 3x equals 3 with the curve they are 0, 3 and 1/2 3/2. And those are our points of intersection, and that concludes this question on parametric equations.